Hello and welcome back to Atomic Math. Since the World Cup is happening, I thought this was a perfect opportunity to use soccer to explain projectile motion. So let's get right into it. A soccer ball kicked by a player is a perfect example of projectile motion. We'll look at a couple different kicks and we'll determine if they would have scored a goal. Imagine you are about to take a penalty kick and you are 11 meters from the goal line. And you know the exact position that the goalie will leave unprotected. On the goalie's right side, there is a square opening measuring 30 centimeters by 30 centimeters. And you know from history that this spot is generally left unprotected. Now, the bottom of this opening is going to be 18 centimeters above the ground. So you kick your ball, and the ball has a radius of 11 centimeters and a speed of 20 meters per second at an angle of 11 degrees above the field. So for this question, we're going to ignore air resistance and we're going to treat the ball as a point. So the question is, will the ball pass through the opening? Will you score a goal? First of all, whenever working with questions like this, it's so much easier to start with a picture. So we know that there's going to be this goal line, and we're trying to fit through this tiny little opening. First thing we know this opening is 30 centimeters. We also know that it starts 18 centimeters above the ground. And we know that we are 11 meters away from the goal line when we take our kick. So in order to be successful in getting a goal, we need the height of y to be between 0.18 meters and 0.48 meters when x reaches 11 meters. Now, that's actually too simple. Because the ball has a radius of 11 centimeters and we are only calculating basically the point, so the center of the ball, we need to allow for that. So at x equals 11 meters, we actually need the center of the ball to be between 0.29 meters and 0.37 meters. So that's going to be the range that tells us whether we're going to score a goal or not. So now that we have that, let's look at everything else that we know. We know that our initial x is 0, our final x is 11 meters, our initial y is 0. We don't know our final yet for y, that's what we're going to figure out. And we know that our initial velocity was 20 meters per second at an angle of 11 degrees. So now that we have everything pulled out of the question, we have all the data we need, we can now start working with that. And to work with that, we're going to need some equations. Now, I always organize my equations like this. I find it very helpful, especially for students, to easily pick out which equation you should be using. Whenever you're doing a question, there's always going to be a variable that you don't have, but you're also not looking for. And so that missing term, you look in that column, whatever it is, that's the equation you choose. The first step is always going to be to separate x and y components of the velocity vector. If we have this vector, we know that we can split it into its x component and its y component. And for this particular triangle, we know that our hypotenuse is going to be 20 meters per second, which is our velocity vector, and our angle is going to be 11 degrees. So to find our x component, we're going to need to do 20 cos theta, and to find our y component, we'll do 20 sine theta. So for the Vx, we're going to do 20 cos 11, and we're going to find a x component of 19.63 meters per second. For the y component, we're going to do 20 sine 11 degrees, and we're going to end up with 3.82 meters per second. So now that we've split our vector into our x and y components, now we can start working the problem. So the first thing we're going to do is work with the y component, and we want to determine the height when the vertical velocity becomes 0. I'm not talking about time here, nor am I looking for it, so I'm going to pull the equation out that doesn't need time. And if we rearrange this and change our x's to y's, we're going to get an equation like this. Now, we happen to know that our initial y is 0 because we're starting from the ground. We also know that our final velocity is going to be 0 because that's what we're trying to figure out, how high when the ball stops moving up. So this equation is going to simplify down to this. And if we plug our values in, we're going to find our v final to be 0.74 meters. So the ball will reach a height of 0.74 meters before it starts coming back down. So now that we have that, let's determine how long did it take for the ball to reach that point. Now, the easiest question to find the time is this one here. And as I said, we already know that v final is going to be 0, so this is going to rearrange and simplify to this. And if we plug our values in, we're going to find that it takes 0.39 seconds to reach that 0.74 meters. So we can save that, put that up there. Now let's look at the x direction. The x direction, because we're ignoring drag, will have a constant velocity. So nothing is going to affect the velocity in the horizontal direction. And we determined that that horizontal velocity is 19.63 meters per second. So in order to find the time for this, I'm just going to simply use this because, as I said, we're using a constant velocity. And if we fill our numbers in, we have 11 meters over 19.63 meters per second, and we're going to find a time of 0.56 seconds. That's the time the ball takes to go from the moment it leaves your foot to the moment it reaches the goal. Now, for the y component, we know that it's already used 0.8 0.39 seconds going up. So that only leaves 0.17 seconds for the downward portion of the journey. So we need to figure out where's that ball going to be at 0.17 seconds. Okay, so let's move this up now that we have that. So because we're not looking for what is the final velocity of the ball when it gets to the goal, we're going to use this equation here because we don't care about that term. For this, we know that our initial velocity is 0, so this whole term is going to just disappear. And then if we change our x's to y's and rearrange this, we're going to have this. Our v initial is going to be that 0.74 meters because that was the height of the arc, and now we're starting from the top. And of course, we have gravity and our 0.17 seconds. So when we calculate that, we get this. Now we need to move that 0.74 over, and that leaves us with a y of 0.60 meters. So the height from the ground that the ball will be when x equals 11 is 0.60 meters. Now, unfortunately, that puts us outside of our box of 0.29 meters to 0.37 meters, so we would not score through the pocket. Now, suppose that you got a second chance. You get another kick, and this time you're going to kick the ball with an initial velocity of 22 meters per second at an angle of 8 degrees because you learned from your previous attempt. This time, I broke down the components for us, so our Vx is going to be 21.79 and our Vy is going to be 3.06 meters per second. I'm not going to derive every equation this time because we've already gone through it. I'm just going to jump right to the final step for each one. So our y top, the height that we reach, is going to be basically 0.477 meters. And our time to reach that point is going to be 0.31 seconds. And our time for the ball to reach the goal in the horizontal direction is going to be 0.50 seconds. So to figure out the y final, we're going to need to remove the first part of its journey, which was 0.31 seconds, and that's going to leave us with 0.19 seconds. So this time our ball will have 0.19 seconds of falling before it actually hits that goal area. So now that we know all of that, we can actually jump right and calculate our y final. So we're set up pretty much the same. It's just our initial y is different, and of course our time is different in this one. So once we plug all our numbers in and solve, we can see that we have 0.30 meters. And since this is within our 0.29 meters to 0.37 meters, the ball does get through and you score, but you were very, very close. So I hope this video was helpful in explaining projectile motion. I thought it was a fun way to look at something that people often struggle with. If you like this video, go ahead and hit like, and if you want to see more videos like this, hit subscribe. See you in the next video.